In the vast black expanse of the universe where galaxies collide and stars are born in clouds of fire and dust, one of the most violent events imaginable unfolds in utter silence. A supernova, a massive star's explosive death, is one of the brightest, most powerful outbursts in the cosmos. It releases more energy in a few seconds than our sun will generate in its entire lifetime. And yet, if you were close enough to witness this colossal event, you wouldn't hear a thing. No roaring blast, no echoing boom, just absolute haunting silence. This is not just a poetic image, it is a profound scientific reality. In this video, we will explore the strange and beautiful paradox of the silent supernova. We'll uncover the physics behind sound and why it cannot travel in space, examine how these stellar explosions reshape the universe, and reflect on what it means for the loudest events in existence to be utterly mute. And perhaps in that silence we may come to understand not only the universe a little better, but ourselves. To understand the silence, we must first understand the explosion. A supernova marks the end of a massive star's life. Throughout its life, a star maintains a delicate balance. The outward pressure from nuclear fusion pushing against the inward pull of gravity. But when a massive star, typically more than 8 times the mass of our Sun, runs out of nuclear fuel, that balance breaks. Gravity wins. The core collapses in a fraction of a second. The outer layers fall inward, striking the core at incredible speeds. This causes a rebounding shock wave that blasts the star's material into space. In that moment, a supernova is born. These explosions are so luminous that they can briefly outshine an entire galaxy. The supernova SN 1006, for example, was visible from Earth in daylight for weeks in the year 1006 CE. Another, SN 1987A, was observed in 1987 and offered scientists the closest modern glimpse into such a phenomenon. But here's the crucial point. Sound is a mechanical wave. It requires a medium, such as air, water, or solid matter, through which particles can vibrate and pass energy from one to another. Without a medium, there is no sound. And space, contrary to its often colorful portrayal in science fiction, is a vacuum. It contains atoms and particles, yes, but they are so sparsely distributed that they can't carry mechanical waves. So when a star explodes in deep space, there are shock waves of energy, there is light and radiation, but there is no sound. If you were nearby, with your ears protected from the lethal radiation, you'd see the explosion, but you'd hear nothing. This is not science fiction. It's physics. In movies, spaceships explode in fireballs, accompanied by dramatic bass-heavy booms. But in reality, there would be silence. The explosions would unfold in total stillness, no matter how devastating. Supernovas come in various forms, mainly categorized as Type 1 and Type 2. Type 1 supernovas occur in binary systems where a white dwarf star accretes material from a companion star. When it gathers too much mass, it can no longer support itself and detonates in a thermonuclear explosion. Type 2 supernovas, on the other hand, involve massive single stars. When fusion can no longer continue, the core collapses and triggers an explosion from gravitational energy. Both types release enormous energy. Both types send shockwaves, radiation, and stellar debris across space. Both types create the building blocks for new stars and planets. And both types are equally silent. Let us imagine you are floating in space, observing a star on the brink of death. You see the sudden blinding flash as the supernova erupts. You watch the material spiral outward in beautiful arcs. You might feel the pressure of passing particles. If you're far enough to be safe, you'd witness one of the universe's most spectacular displays, but not 1 decibel of sound would reach you. This contrast between visual grandeur and audible emptiness makes the supernova one of the most poetic cosmic phenomena. It is a storm of light without thunder, a cry of creation that cannot be heard. On Earth, if a supernova happened close enough within a dense atmosphere, the sound would be catastrophic. The explosion could potentially produce sound pressures that exceed our atmosphere's capacity. But no supernova has occurred near Earth in modern human history. Scientists have attempted to imagine what a supernova might sound like if space had a medium. Using simulations and sonification techniques, they've transformed data into audible sounds. These aren't real recordings, but artistic interpretations based on pressure waves, light curves, and gamma-ray bursts. NASA has even created musical renditions of various astronomical phenomena, turning data into symphonies. In a sense, we are giving the universe a voice, one it does not naturally possess. Here's a remarkable twist. While supernovas are silent, they are anything but lifeless. These explosions scatter the elements necessary for life across galaxies: iron in your blood, calcium in your bones, the oxygen you breathe. All were forged in the hearts of stars and released by supernovas. We are, quite literally, the children of silent destruction. Every breath you take is a whisper from a star that died millions or even billions of years ago. Every heartbeat echoes a process that began with a cosmic event you could never hear. The irony is powerful. Life exists because of a soundless death. Although sound does not travel through space, modern astronomy has begun to experiment with sonification, converting astronomical data into sound. Using X-ray, visible light, and infrared data from telescopes like Chandra and Hubble, scientists assign tones and pitches to represent different intensities and wavelengths. The result? Soundscapes of nebulae, galaxy clusters, and yes, supernovas. These artistic representations allow us to engage with cosmic phenomena in new and immersive ways. We are not hearing the universe directly. We are translating it into something our senses can grasp. And in doing so, we find new meaning in its silence. Now imagine this. What if there are forms of life out there that don't rely on sound as we do, but interpret space through entirely different senses? What if their biology allows them to interpret electromagnetic pulses as vibrations? What if they can detect gamma rays the way we detect noise? In that case, the universe is not silent at all. It's singing in a spectrum we simply can't perceive. Perhaps supernovas do have voices, just not for us. Silence in the face of cosmic destruction is both chilling and awe-inspiring. We often associate silence with peace, but in the universe, silence can mean the collapse of a star, the death of a solar system, the birth of black holes. It challenges our human senses. We rely so much on sound to interpret our world. And yet, the cosmos teaches us that the most powerful truths may come not through hearing, but through observation, through feeling, and through understanding. The silent supernova is not just an astronomical event. It is a metaphor. It reminds us that absence of sound does not mean absence of meaning. In a universe governed by laws more vast and complex than our minds can grasp, a star dies, it unleashes the energy of billions of suns. It forges the atoms of future planets, plants, animals, and civilizations. And it does so in silence. The silent supernova is not a failure of perception. It is an invitation to expand our senses, to explore beyond the familiar, to listen not just with ears, but with imagination. Because sometimes the loudest truths are not heard, they are understood.